In this video, we'll look at how can we use the graph to do the diagnostics. So we introduced the diagnostic at the end of chapter 14 and 15 because this is the last step for our regression analysis, diagnostics. So what is diagnostics? Actually, diagnostic is using a graph or statistics to test our model assumption is valid or not. It will perform at the end of the regression analysis because we want to use the model result to create the statistic or the graph to test if our assumption is valid or not. In order to do the diagnostic, we need to mention about the residual analysis. So the residual analysis is using the residual against certain variable to create the graph to look at the pattern and compare the pattern with the correct pattern to see if the assumption is valid or not. So the residual is you're using the y variable minus the estimated y variable based on your model, get the residual. So for a simple linear regression model, the residual plot against the y-hat and the residual plot against the x provide the same information. However, in the multiple regression analysis, it is preferable to use the residual plot against y-hat to determine if the model assumptions are satisfied. So now we talk a lot about assumption. So what are the assumptions imposed on our regression model? So here we have 4 assumptions imposed on our linear regression model. So the first, the relationship are linear. So how can you interpret this? So when we write down the regression equation, y-hat equal to b0 plus b1x1 plus b2x2 plus b3x3 plus bkxk. So we already assume that the relationship between x and y are linear. However, we do need to examine it before we can submit our confirm our we are happy about the regression result. So we will test the linear relationship assumption is validated or not. So the second assumption is that the standard deviation of the residuals is the same regardless of the given value of x. So in this case, we will look at the relationship between the x value and the residuals, or the residual and the predicted y value. And assumption 3 is the population of errors or residuals is normally distributed with a mean 0. So for assumption 3, obviously we need to test the 2 aspects. The first is the normally distributed of the characteristic, and the second is the mean 0. So in that case, we will use 2 different graphs to test the exam 3. One for normality assumption, another is for the mean 0 assumption. So assumption 4 is the residual are independent of each other. So we want to make sure the residual not correlated with each other. So we will use another graph to test the assumption 4. So first, let's look at what kind of graph we can use to test the assumption 1 linear relationship. So for the first assumption linear relationship, we will use a scatter plot, and the horizontal axis is x, and the vertical axis is y. So in that case, if we have 3x in our model, we need to create 3 scatter plots with fit line to see if each x has a linear relationship with y. So now let's look at assumption 1. In what condition we will think the assumption 1 is not violated? So here is an example. So the vertical axis is y variable, and the horizontal axis is x variable. And you can see the trend line is in the center of the observations, and those observations are evenly distributed around this trend line. So how can we describe this scenario, this situation? So when there is no curvature for the scatter plot, and they are not scattered too far away from fitting line, and we think the assumption 1 is not violated. So if assumption 1 is violated, how it may look like? So here is 3 examples that assumption 1 is violated. So for the first one, if you look at this one, you can find we have majority dot is under this trend line, and we only have 3 dots above this trend line. So what happened for this scatter plot? So this happens because we have one observation is far away, far from our trend line. So obviously for this graph telling us the linear assumption may violate it. And how about this one? So for this one, if you count how many observations above this trend line, only 2 or 3. And majority of them is below this trend line. And also, if you try to use a line to link all the observation here, you will find actually it looks like a curve instead of straight line. So obviously, in this case, the assumption 1 linear relationship is violated as well. And how about the last one? So we don't need the trend line for this case, because obviously this curve, this observation is showing us a very obvious curve. So we will not use the linear relationship to relate x and y. So talking so much about what is an ideal case for assumption 1 is not violated. So how can we find this plot in our regression or Excel? So let's go back to look at our GPA and the GPA and years age, student age, and the class standing example. So after we got the regression equation, and when I ask you to get a regression equation, and at the same time I also require you to check 5 boxes to get this plot. So you should have a many plot for this example. So in order to find the plot you can use to test the assumption 1 is you find the plot with 3 words, line fit plot. So we have line fit plot. We totally have 1, 2, 3, 4 line fitted plot because we totally have 4x. So first, let's look at the first plot. The first x versus y. The x versus y plot. So the x1. So in this plot, you can find we have orange dot. That's a predicted value, so we don't need it. So first, delete. Choose any orange plot, and find the delete button on the keyboard. Delete them. So now you only left the blue dot. That's the GPA. Then choose any of the blue dot, and right-click the mouse, and find add trend line. And choose the linear one, and you can close it. So now from this plot we can find we only have 3 since we only have 7 observations, it's hard to see if our first assumption is violated or not. But for another thing you can find is the majority plot is located on this area and only 1 dot is there, so which means this line cannot really pretty good to portraying the characteristic of our dot. So the linear line is not a good relationship to relate x1 with our y variable. So in this case, we think there is. So then you can go back to look at our slides. So although we didn't see the curvature, but we found some scatter is too far away from our feature line. So assumption 1 is violated. So you can use the same idea to look at the second one for the x2. So for this one, I want to mention something very interesting because we know we know for x2 that is a categorical dummy category. The x2 is a dummy variable, either 0 or 1. So that's why you will see this weird graph. Then first delete orange dot. Now you will have some blue dot. So how can you decide the linear relationship is violated or not? So obviously it's hard. Yes, you are right. So for dummy variable, we will not use our plot to test if the linear relationship assumption is violated or not. The linear relationship assumption is used to test our quantitative variable, not a categorical variable.